Now we're going to practice expanding logarithms more. So at this point, we already know our product rule, our quotient rule, and our power rule. So the instructions say use properties of logarithms to expand each logarithmic expression as much as possible. So when we're expanding, first we're going to apply the properties of logarithms, product, quotient, power rule. And then second, if we can, we'll keep on simplifying. So if we can evaluate a log and write it as like a 2 or a 5, we want to go ahead and do that as well to fully simplify. All right, and with the product and quotient rules, you'll start with one log and you'll end up with 2 or more logs. We're splitting up this log with our ax into multiple logs, just as a reminder. So that's what it means to expand. All right, so for number 5, expanding log base 3 of 81 over 4, we're going to use the quotient rule, right? Because we've got a big fat quotient right there. So that means we're going to subtract. That division symbol looks just like a subtraction symbol, if that helps you remember. So log base 3 of 81 minus log base 3 of 4. And we can simplify log base 3 of 81. Remember, this is asking us 3 to what power equals 81. And go ahead and double check in your calculator, but if I'm remembering correctly, I think 3 to the 4th power equals 81, and I'm right. So log base 3 of 81 simplifies to 4 minus log base 3 of 4. Number 6, common log, so log base 10 of 100 times x. In there we've got a product, right? So we're going to use the product rule. So we've got log of 100 product rule plus log 100 plus log of x. I'm splitting one log into 2 logs. And can we evaluate this further? I'm glad you asked. Remember, we have the common log, which even though we're not writing it, if you want, just as a reminder, common log means there's a little base 10 there. So we don't actually write that as a final answer, but just a reminder that that exists. So this is basically saying 10 to what power equals 100. And I know that 10 squared equals 100. So this guy simplifies to 2 plus log of x. Now, the nice thing about your common log is you can even more easily check that in your calculator. Because it's common log, I can say what's the log of 100 if I'm doubting myself, and it's 2, so I got it right. Okay, super. Let's go to number 7, natural log of e divided by 3. I've got a quotient minus. So natural log of e minus natural log of 3. And again, the natural log, even though we don't write it like this, remember that the natural log has a little base e. So it's saying e to what power equals e, and the answer is 1. Or just because this natural log stuff is super weird, right? So go ahead and use your calculator. You got it. So just to double check, what's the natural log of e? So if I hit second and the ln key, there's e. It's asking for an exponent, so e to the first is e. And there's my 1. So I know that this first term simplifies to 1, and I end up with 1 minus natural log of 3. All right, number 8, the common log of the 5th root of z. So again, when you're working with logs, because a log is an exponent, it's usually preferable to convert this radical notation into rational exponent notation. So before I even start expanding anything, I'm going to rewrite this as the log of my base z raised to the power 1/5. This is equivalent to the 5th root of z, z to the 1/5. Now in expanding, I'm not going to get 2 logs here, but I am going to be able to apply the power rule. So I'm going to take that power and move it out front as the coefficient. So 1/5 times the log of z. And if you want, you can write that multiplication symbol if it helps you sleep at night. So 1/5 times the log of z is fine, or just 1/5 log z. It's implied that they're multiplied together. All right, moving down to number 9. Common log of x plus 4 divided by x. We have that division sign, which looks like a minus sign. The quotient rule means we're going to subtract 2 logs. So I'm going to split this up as the log of x plus 4 minus the log of x. Now, the way I wrote this isn't quite correct, and I want to use a different color just to kind of give you a visual reminder. Right now, what I wrote is the log of x, and then a plus 4, and then a minus log of x. So because we have that binomial expression in the numerator, we've got two terms in the numerator, you need to sandwich those together with parentheses, okay? So when you have two terms, make sure you put parentheses so that we know that we're taking the log of that entire sum, x plus 4. Without the parentheses, it's a wrong answer. All right, and from there, we can't really do anything else. We can't evaluate or simplify because we've got x's in both expressions. So we're done. Boom. All right, moving on to number 10. We've got log base 5 of x plus 1 times x plus 2. Using the product rule, we're going to split this into two separate logs added together. So this is log base 5 of x plus 1 using my parentheses plus log base 5 of x minus 2. And again, we can't simplify, we can't evaluate, we can't do anything else, so this is it. All right, let me pause real fast before we get into these trickier examples. I know logs are weird, guys. I know it's weird. One thing I just want to make sure you're not doing is a log isn't a number. A log isn't a number. It's an exponent, but it's not a number. So it's not a constant. So I know if we had like 5 times x plus 1 minus 3 times x minus 2, we'd say, oh, cool, we can distribute. That's 5x plus 5, right? Blah, blah, blah. You can't distribute a log. So you can't say, oh, cool, this is log base 5 of x plus log base 5 of 1. It doesn't work like that. So please don't treat it like that. You can't distribute it just like you would distribute a 5 or distribute a 2. A log isn't a constant. It's an operator, okay? So log base 5 of x plus 1, just leave it alone. Don't touch it. Don't try to get cute. Don't distribute it. You're done. Walk away. Okay, so there's my PSA for the day. All right, so on to 11 and 12. So these guys get a little trickier because now we're going to be applying multiple rules at the same time. So looking at number 11, let's see what color I used. Maybe I'll go back to gray here. So for number 11, we have log base 3 of x cubed times y to the 4th. So we have products, but we also have powers, right? The cubed and the 4th. So here we're going to split it up using the product rule first, and then after that we'll use the power rule. So using the product rule, this is going to equal the log of x cubed plus the log of y to the 4th. Now that we've done that, we can further expand this, change colors. We can further expand this by using our power rule. So I'm going to pull these two powers forward. 3 times the log of x plus 4 times the log of y. Okay. Now on to number 12. For number 12, we have the log of x times y cubed. So again, we have a product and we have a power. But in this example, we're going to use the power rule first. The reason is we're taking the log of a product, but that whole product is then raised to a power. So because the power is outside of those parentheses, that's why we're applying the power rule first. So applying the power rule first, I'm going to bring that 3 forward. So 3 times the log of x times y. And next, just switching colors here, next I'm going to use the product rule. So I have my 3 out front, and I'm going to put brackets, and you'll see why in a second. So I have my 3 multiplied by that entire log. Remember that I'm going to split that one log into 2 to expand it out. So using the product rule, that becomes log of x plus log of y. Now, I know I gave you guys that PSA about how you can't distribute logs, but you can distribute a 3. A 3 is a constant, right? So I can go ahead and distribute this as 3 times the log of x plus 3 times the log of y. And that's my final answer. So in number 11, we use product rule first because we have a product of two bases raised to two different exponents. So we do the product first, and then individually we do each exponent. In number 12, because the exponent was outside of the parentheses, that's why we ended up doing the power rule first. All right, on to 13 and 14. For number 13, we have the log of x squared over y to the 7th. This is going to be a quotient rule first. So we've got log of x squared minus log of y to the 7th. And then we can go further and apply that power rule. So this is 2 times the log of x minus 7 times the log of y. And that's it. We're done. We walk away. Now number 14, I kind of cut off the top of that radical there, but we've got the log of the cube root of x divided by y. And remember, with logs, it's helpful if we can first convert into an exponent notation instead of a radical notation. So I'm just going to rewrite this as log of x divided by y. That's our entire base under the radical. And I'm going to raise that whole guy to the power 1/3. The cube root of x over y is equal to x over y raised to the power 1/3. All right, so because we've got that power outside of the parentheses, just like we did in number 12, guess what we're going to do first? The power rule. All right, so applying the power rule first, I'm going to rewrite this as 1/3 times the log of x divided by y. Don't really need the parentheses, but they can't hurt. And next, I'm going to apply the quotient rule. So the quotient rule, I'm going to subtract. I have my coefficient 1/3 on the outside. I'm going to write those brackets. Log of x minus log of y. And I can go ahead and distribute that 1/3. 1/3 log of x minus 1/3 log of y. Okay, and in 15 and 16, it says again, expand completely. So we're still expanding here. So lots going on in this one. Number 15, log base 5 of 25x divided by y squared. So I see a product, I see a quotient, and I see an exponent. All right, so first let's look kind of at that overall quotient. So I'm going to break this into log base 5 of 25x. Don't need the parentheses, but I'll pop them in there because it can't really hurt. Minus log base 5 of y squared. So I'll start there. So I use my quotient rule first. And just keep asking if you can continue to expand. Right here, log base 5 of 25x. I have a product, so I can go ahead and apply the product rule. Log base 5 of 25 plus log base 5 of x. And then over here, I have minus log base 5 of y squared. I could apply the power rule here. So I'm going to write minus 2 times log base 5 of y. And last but not least, remember I want to fully simplify if I can. Log base 5 of 25 is saying 5 to what power equals 25? And that's just 2. So now for my final answer, I have 2 plus log base 5 of x minus 2 times log base 5 of y. All right, number 16. Natural log of the 5th root of x, y to the 4th divided by 16. Lots of stuff going on. But the first thing I want to deal with is I'm going to change that 5th root to a rational exponent. So natural log of my base, x, y to the 4th divided by 16. I'm going to raise that to the power 1/5. So 5th root, exponent 1/5. Now the power is on the outside, so I'm going to attack that first because the power is outside of those parentheses. Oops, can't write. Oop, there we go. Okay. So because the power is outside the parentheses, I'll apply the power rule first. So 1/5 times the natural log of xy to the 4th over 16. And I'm going to keep that 1/5 on the outside of all of this. Continuing to expand, I've got my quotient rule next. So I can break this into the natural log of xy to the 4th minus natural log of 16. And then I've got a product in here. So let's keep picking away at this guy. Oops. So I've got my 1/5 on the outside this whole time. I continue carrying it down. Natural log of x plus natural log of y to the 4th. And then I just continue carrying down that minus natural log of 16. And the last thing that I need to do, well, second to last. So I can go ahead and pull forward that 4 just in front of that single natural log. So I've got 1/5 times the natural log of x plus 4 times the natural log of y minus natural log of 16. And I'm going to scoot down here because I'm out of room. Then final step is I'll go ahead and distribute that 1/5 to all three terms. So this equals 1/5 ln x plus 4 times 1/5 is 4/5 ln y minus 1/5 ln 16. Isn't that pretty? The end.